We doing math today. Ain't got time for no games. We doing math today. All work and no play. We doing math today.
Alright, let's go over C1. The distance between 2 points on a coordinate plane, grid D, can be calculated by using the equation D equals x2 minus x1 squared plus y2 minus y1 squared, where x1 and y1 represent the coordinates of one point and y2 represent the coordinates of the other point. Identify the points on the x-axis. So let's draw a picture. That is exactly 8 units away from point 2, -3. So 2, -3, right 2, so that's your x, y. So we need something that is exactly 8 units away from here. And you can use that formula. So we'll just write down the formula. D equals all this. And there are easier ways to solve the problem, but they want us to use this formula. Okay, so D is equal to 8. And it wants us to be on the x-axis. Okay, so this tells me, okay, let's call this one x1, y1. And that second one I'm going to call x2, y2. Okay, so let's go ahead and substitute that in. So x2 is 2, and y2 is -3. I'm going to put everything in there. Okay, pink. Our x1 is, we're going to call it x. Pink. And y1 is 0. Okay, and basically if you think about what we're doing here, all we have to do is just solve for x. So 8 equals 2 minus x squared. So this again is, we've been doing these quite a bit. And -3 minus 0 is -3, and -3 squared is 9. Okay, so I'm going to go ahead and multiply this one out over here. And I will get 4, -2x, -2x, and x squared. So we have x squared, -4x plus 4. And combine like terms, so you have 8 equals square root x squared minus 4x plus 13. I can square both sides, get rid of this radical. So I'm going to get 64 equals all of this. And then I'm going to subtract 64. So I'm going to get 0 equals x squared minus 4x. And get my calculator here, -64 plus 13. 13 minus 64 gives me -51. Okay, so see if we can solve this by factoring, hopefully. A is 1, -51, and -4. What are the factors of 51? Double check this really quickly. Okay, it doesn't appear to be any, so we get the awesome privilege of doing the quadratic formula. So let me take this, duplicate that. Let's do this up here. Let's erase some things. There. Okay, so A is 1, B is -4, and C is -51. Quadratic formula, if you sing it, x equals -b plus or minus square root b squared minus 4ac all over 2a. Okay, so my b value is -4 plus or minus b -4 squared minus 4 times the a value, which is 1, and our c value is -5 all over 2 times 1. So opposite of -4 is +4. I get 16, and -4 times 1 is -4. -4 times -5 is +20. So we're gonna get x equals 4 plus or minus square root 36 over 2, and let's just work on it up here. So x equals 4 plus or minus 6 over 2. Oh gosh, it is -51. Big doo-doo. 4 times 51 gives me 204. Let's see, 51 times 4 gives me 204 plus 16 gives us 220. Messed up here. Okay, and let's see, 4 plus or minus these. 4 goes into 22. Let's see. 55. Okay, so the square root of 4 is 2. And if you factor out a 2 from all of this, there's like a 1 right there, right? You can cancel the 2's, and your answer is going to be x equals 2 plus or minus radical 55. Remember that plus or minus basically means it's x equals 2 plus radical 55 and x equals 2 minus radical 55. So these are our answers. Basically, if let's just put that in. Radical 55 is like 7.4. So 2 plus 7.4 gives you kind of like 9.4, and then negative 5.4. So we're basically saying that the distance can be here. This would be a distance of 8, or in blue, this could be the distance of 8. Okay? All right, let's try a different one. Apply the same thing, just a little bit different. Let's draw a picture. And it tells me we're starting at -3, -4. So left 3, down 4. And let's just call this one x1, y1. Okay, now we have a distance of 5. And we have on the y-axis. So can't see that one, but it says 0, y. So this will be my x2, y2. I'll put in 0 for x2, and then for y2, I'll put in the coordinate 0. All right, so let's go ahead and put this in. D equals x2 minus x1 plus y2 minus y1, and each of those are squared. Our d value is 5. My x2 value over there in orange is 0. And my y2 value is the value y. In pink, my x1 value is -3, and my y1 value is -4. And I'm going to put in everything back in white. All right, let's clean this up. So I have 5 equals 0. Opposite of -3 is +3, so 0 plus 3 is 9, plus y plus 4 squared. Okay, so I'm going to do the y plus 4 squared is really just y plus 4 times y plus 4. And this will give us y squared, 4y, and 16. Combine those two, and you will get y squared plus 8y plus 16. And then we have this 5, and we have that 9. So I'm going to add these two. I'll get 25. I'm going to square both sides, get rid of the radical sign. And then I'm going to subtract. And we'll get 0 equals y squared plus 8y. This problem's super nice because we can solve it by factoring, take out GCF. And then I'm going to set each of these equal to 0. Do it over here, have some space. So I have y equals 0 and y plus 8 equals 0. So that's a solution, and y equals -8 is a solution. Okay, so if you put those back in here, you'll get two answers. You'll get 0, 0, and 0, -8. 0, 0, and 0, -8, just down here. And basically, this has a distance of 5, and this also has a distance of 5. So those are your two coordinates. Let's move on to C3. The radius of a circle on the coordinate plane. So there's my coordinate plane. There's my equation where x represents the x coordinate and y represents the y coordinate on the circle. Determine the x coordinates of a point x, 6. All right, so I don't know what the x value is. We'll just call this x, and that's my y. Let's use a different color. X, y, and then this is your r value. So let's write down that formula. And let's just plug in all of our numbers here. So there goes our x, there's my y, and there's my r value. So r is 8, x value we don't know, y value is 6, and 8 equals x squared plus 36, and we'll square both sides to get rid of it. Remember, we've been learning that this 2 and this invisible 2 with the radical sign are gone, so you're just left with what's inside the radicand, which is 64. And subtract 36. I'm going to solve this by the square root method, so 18, 5, 28. And remember, every time you take the square root, you're going to have plus or minus. They call that the principal root. Or we want both, actually positive and negatives in this case. So this would be 4 and 7. So that would be 2 radical 7. So x would represent 2 radical 7. If I put that in my calculator, I'm probably going to type in 7 radical times 2 gives me like 5.29. So positive 5.29 and 6 be like this. And if you did the negative 5.29, oh, I think negative 5.29, because x is with a comma 6. So this point and this point, they're on this circle. To determine the x-coordinate of on a circle with a radius 8. So wherever the radius is, this is distance of 8. Okay? Alright, C4. The minute you drive a newly purchased car off the lot, its resale value drops immediately. The equation, R equals 1 minus cube root of V divided by C, models a car's immediate resale value. So before I even read the rest, I'm actually just going to write down this formula. Because they're probably going to tell us a bunch of stuff. Does that make sense? And I might as well just start plugging in. Where V represents the immediate resale value of the car. Okay. C represents the original cost, and it tells us, and R represents the depreciation rate. So determine the resale value. So this would be the orange part, which would be V. So we've got to solve for V. Let me write that. I like writing that. Determine means that V is an unknown. That's what you're solving for, this variable. Okay, the original cost is in light blue, right? We said the original cost is C, so it's telling you it's this number is going to be a big number right there. 29,500. And R is the depreciation rate. Oops. And that's going to be 7%. Round your answer to the nearest cent. Okay. Let's put in, okay. Now, a depreciation rate, I'm not quite sure, so let me try this. If your car doesn't do anything, it's 100% right off the value, right? And then it's losing 7%. So remember, to change a decimal into a percent, you're going to move it 2 decimal places. 1, 2, because it's really 7 divided by 100. 7 parts out of 100. So this would give us a 0.97. But let's just see. Let's just put in this 0.07 because it's telling us the rate. Let's figure out. Let's see what happens. Okay. Yeah, it does make sense. Watch. I can tell. If I want to solve for V, I want to get rid of all that stuff. And in order to do that, I'm going to use PEMDAS. And you are solving, so you're going this direction, and I need to do the addition and subtraction. So if I subtract 1 from this, I'm going to get a negative 0.93. That's how I knew that rate was good. Okay, I need to get rid of that negative sign, so you can multiply both sides by -1. And I'm going to get 0.93 equals the cube root of v over the cube root of 29,500. Okay, so I'm just going to use a calculator ready equation. That just basically means I'm going to multiply both sides by 29, the cube root of 29,500. Okay, so I got this. And if I put that into my calculator, so now I have, let me do this with you. Let me take a quick picture, then I can show you using mine. All right, so we are going to do the 0.93 times the math cube root of 29,500. Okay, it's going to give us this number now. Then, to get v by itself, I'm going to have to cube it. So if you take the answer, just don't touch anything, and put the caret, which is above the division sign, and to the third power. So 28.7 to the third power, essentially. And you're going to get some very large number. There it is. Yeah, that's the number I wanted. So I'm going to take a picture of this, and then I can put that into our answers. It doesn't tell us where to round, so generally rounding is just so let's review what we did. We just multiplied these two, and I got 28.73582172 equals the cube root of v. And to basically get v by itself, I'm going to have to take it to the third power. This 3 and this 3 and the radical sign, so you're left with v equals $23,728.53. So what's the value of the car with a depreciation of 7%? Using that, it's going to be you're losing what, like $5,000 or $6,000. That's amazing, right? All right, C5. The speed in meters per second of a tsunami can be determined by using the formula S equals 9.8 D. Okay, so now they're going to define some stuff for us, where D is the depth of the ocean in meters. Suppose a tsunami is traveling at a speed of 8.3 kilometers per second. Okay. How deep is the ocean at that point? So this one is more like, what is D, right? How deep is the ocean? Now, it tells us to convert kilometers into meters. Okay, so I like to do conversions by writing them out. And what they gave us for that speed is 8.3 kilometers. Are you following? And I want to know, what is this speed in meters? So I can cross multiply. I'm going to get 1 kilometer x equals, you don't even need that, right? Put a bunch of zeros, and this has 3 zeros, so you just multiply 1, 2, 3. So 1 km x equals 8300. Pen, come to me. Remember, I don't need that extra 0. This one is km times m. So then if I divide both sides by km, you're going to get this. Okay, so now I have it in meters. So my speed is 8,300, and I just need to solve for d. So square it, and I put this into my calculator. You're going to get some really big number times 8,300. You're going to get 68,890,000. Remember, this 2 and this 2, the visible 2 and the radical sign are gone. And divide both sides by 9.8. So I'm going to divide that answer by 9.8. And we will get the depth to be about 7,029,591.84 meters. Now, this problem didn't tell me how they want their answer, so this should be good enough. Okay. If you wanted to go back to kilometers, you can do that, but I'm going to keep it in meters. And C6. Melissa deposited $2,580 in an account 3 years ago. The interest rate is compounded once a year, and the equation is, let's write this down, R equals cube root of A over 2580, and that minus 1 is on the outside, where A is the current balance. Can be used to calculate, are we missing something there? Okay, if the interest rate is 3.5%, I'm going to assume that is R. So remember 3.5%, and as a decimal, you move it 2 places, so that would be 0.035. How much does Melissa currently have in her account? So current balance is A. So we're essentially solving what is A, right? Okay, so let's just use all of our math skills. Now remember, with radicals, you can do this. It's perfectly fine. And temptation for students is just to use their calculator, but just wait, okay? Let's get rid of that one. Right, I'm solving for A. This is the PEMDAS backwards. So I'm doing this part right there. $1 plus 3.035 is 1.035. Okay. And I'm going to multiply both sides by 2580 cube root. Okay, so here, these will cancel. Okay, I have a calculator ready equation. So let me take a picture of this one again so I can input it for you. Okay, so I have cube root math number 4. 2580, and then to get out you press right key and then enter bottom right. Okay, you get this number, don't touch it, and then I'm going to times 1.035, and we get this number. So let me copy this number. Okay, so if you go back to your work, we just said and all of this number was 14.19537,659. I don't like to round, I just like to keep them all. And it's already in our calculator, so we don't have to do anything, but we're kind of just doing this algebraically. So you're cubing it now. And this means this cancels, this cancels, this cancels. You're left with what am I trying to say? What does she currently have in her account? That's the A value. Okay, so let's just take that number and then put it to the third power. So the nice thing, it's already in there. You just need to do the caret, or to the third power, which is to the right where it says pi, kind of. Okay, and then mine's messed up, so I just pressed math and I went number 2 decimal. And that's our number. 2860.49. 2860. 2860.49. That's pretty good, right? She originally put in 2580. She's probably making like, I don't know, almost $300 in interest in 3 years. It's pretty good. $100 of interest a year. So that is our board problems. We'll see you guys. Bye.